Okay, let's try to go over an example about setting up optimality equation or the Bellman's equation. We look at a modified stock option model, modified from the lecture notes. And for any problem that we wish to model as a stochastic dynamic programming problem, we usually try to see why it's an optimization problem, why we have choices. So in doing this, we can actually identify the action variable. So if you look at this problem over here, so we are first trying to see what kind of decisions, different decisions we can make, and that's the action variable. That's usually a good start. And in a problem, usually it's also easy to identify. If we read this problem carefully, and last sentence over here saying that we try to allocate the amount, total amount A, optimally to be exercised in each period so that the total profit is maximum. And we know that this is a dynamic programming problem, so we have usually n stages, so 1, 2, 3, and n stages. So we have the total amount A over here, and we want to allocate y1 for the first one, and possibly y2 for the second one, and y3 for the last one, and yn for the last one. And the sum of these allocations should be the total A over here. Now, because we are using dynamic programming, really we only look at one day's action. So this is our action variable. We don't even need 1 or 2 or 3 or 4. So we just say action variable over here is y over here. And that's going to be the number of shares, the number of shares to be exercised. Okay, and that's the one we want to look at. Now, how are we going to do this? We know that we need to look at the situation. We look at the factors that we make a decision. Make a decision on the size of this stock option we want to exercise. So now we're going to try to look at the factors that make us, that actually help us to make the decision. So here we can say factors, or the state variables that influence our decision. Or you can say the factors that we base our decision on. And there are obvious ones, for example, how many periods we still have left. And this is the period, how many periods we have still left. We say this is always there, so n is the number of periods. And also, we look at the current stock price. And that's going to be the S. So we start on the first day over here and look at the future. Current stock price is S. And of course, we also have another one. That's number of shares available to us. Number of shares available. Now, for the first period, we have the total number A. But we remember that after the first day, this number is going to change. So we use another variable over here to do that. And that's going to be X. And then after we do this, usually we can actually write down the optimal expected profit. We say Vn XS, this one over here. This is the maximum expected total profit from exercising or exercising all A shares over n periods, and with the current stock price, S over here. And then we can slow down a little bit and try to see what we can actually do with this VnXS. This is what we want to find. Now, how we actually set up the optimality equation, we say let's choose one action and then optimize over all possible actions available to us. So what we do over here is the following. Let's say n is equal to 1. Okay. And that's the last day, the only period we have right to exercise the stock price, the stock option, and assuming that we have X shares. Okay. So what you need to do over here is that we don't have to do, say we know we're gonna need to either not to exercise or exercise all X, but we want to somehow slow down and say it's the last day and we just gonna make a decision to exercise Y, and that means Y is less than or equal to X. Okay. And then we have the following over here. So the stock price is S, so we have V1 of XS. So we will exercise Y, and then we get a profit. We say R of S. And we know what it is. This one over here is going to be the following. If S is greater than, the price C that we have the right to purchase the stock option, then we have, let's say this C is each share, then we have C minus S minus C, that's for each share, and multiplied by Y. And otherwise we get 0. And that's the one we have, the profit. So let's, this is if S is greater than C for each share, and that's what we have. And that's when we exercise Y shares. And then V1 of XS is going to be the maximum, and Y is going to be less than or equal to X and greater than or equal to 0. And we put this RYS over here. So that's when we have only one period. Now, imagine if we have two periods, n is equal to 2. Then what's going to happen? We always assume, so we start with X number of shares. This is available. And then we just exercise Y. Okay. And what do we have? We have the following. We say we have, if you exercise Y, then you have RYS. We don't even need to use the expression over there we have, but we just use a symbol over here, a function symbol over here. And this one will be profit from today. And then we need to add the maximum expected profit from future. Now, because we have exercised Y shares. So we only have now Y X minus shares left. For tomorrow. And tomorrow's stock price we don't know. Tomorrow's stock price we know it's going to be S plus a change. Let's call it T over here. And T is a random variable. And let's say we know it's PDF, the density function. It's going to be the f of t. So this is the one. So in order to find the maximum expected profit from tomorrow, we have to take care of this change to stock price. So what we have over here is that we have the expected value of the best. So with tomorrow we have V1 because we only have one period left. And then we have X minus Y shares left. And stock price is going to be S plus T. That's what we have for tomorrow. And if we want to write down a complete formula, expected value means the integral from negative infinity to positive infinity. And we have V1 and X minus Y and S plus T. We change to lowercase t and multiplied by f of t, the PDF, and dt. So that's the expected value. Expected optimal return, optimal profit from tomorrow. Okay. So now let's put them together. This is what we have. So if we exercise Y shares and we have exercise Y shares, we have the profit RYS for today and the maximum expected maximum profit from the future, and it's V1 and X minus Y and S plus T and FT and DT. Now this is the sum of profit of today and the entire future. It's not optimized yet over today's decision. So now if we want to optimize, then we have V2 X S is going to be the maximum, and Y is less than or equal to X and greater than or equal to 0. And then we have RYS and plus negative infinity to positive infinity, V1 X minus Y and S plus T and F of T and dt. If we look at what we have on the right hand side over here, we see the first term is going to be a function of y with s a parameter. So we have y s over here. S over here is a parameter. And the optimization is over the variable y over here. That's consistent with our assumption. Y is our action variable. And if you look at the second term over here, t is the dummy variable, integrate over here. So when you integrate this function over here, we end up with a function of y, s, and x. So this part over here, in fact, depends on three variables, x and y and s. But y is the variable we are optimizing over, and x and s, both these are parameters. Or you can say state variables. So we always optimize over the action variable. So optimize over y, and with state variable sx as parameters. And now we can write down the general optimality equation just by replacing v2 by vn. Xs is equal to maximum y less than or equal to x bigger than or equal to 0, and rys. This is the profit we gain from today by exercising y shares. And the expected value of the optimal future profit is Vn minus 1, x minus y, how many shares left for the future, and change to the stock price tomorrow with a density function that we are given or we know somehow. And this is called the optimality equation over here, or the Bellman equation.